Welcome to the Pegasus Learning Platform. Pegasus is your home for clinical simulation and learning resources. This presentation may be used for content overview and clinical competency and will cover metric system conversions. It's easier to understand metric system conversions if you understand the concept of the power of 10. The power of 10 is any integer power of the number 10. Don't overthink this though. Basically, when you multiply a number by 10, you move the decimal place one space to the right. When you multiply a number by 100, you move the decimal place two spaces to the right. When you multiply a number by 1,000, you move the decimal place three spaces to the right. And when you multiply a number by 10,000, you move the decimal place four spaces to the right, etc. The same concept applies for dividing. When you divide a number by 10, you move the decimal place one space to the left. When you divide a number by 100, you move the decimal place two spaces to the left. When you divide a number by 1,000, you move the decimal place three spaces to the left. And when you divide a number by 10,000, you move the decimal place four spaces to the left. Let's practice. And remember, when you multiply a number by 10, you move the decimal place one space to the right. So 10 times 10. Now, I don't see a decimal place here, so there's an implied decimal at the end of the number. So we're going to move that decimal place one space to the right, and that's going to give us 100. So the answer will be 100. 100 times 10, so we have 100. We're going to move that decimal place one space to the right, gives us 1,000. 1,000 times 10, we have 1,000. Move that decimal place one space to the right, and we're going to get 10,000, and 10,000 times 10 is going to give us 100,000. Let's try it with some other numbers. So we have 230 times 10. There's an implied decimal at the end. We're going to move that over one space to the right, and that's going to give us 2,300. 43.8 times 10 is going to give us 438. 27.1 times 100, so we have two decimal places we need to move it. So we're going to go 27.1. Let's move that over two spaces. If you have an empty spot there, I always say if you have an empty nest, put an egg in it. So that's going to give you 2,710 and 0.83 times 100. Now we do have a decimal place here, so we're just going to slide that decimal over, and that's going to give us, let's move it over 1, 2, and that's going to give us 83. So let's practice. Remember, when we divide a number by 10, you move the decimal place one space to the left. So we have 100,000 divided by 10, and we need to move that decimal over to the left, and that's going to give us 10,000. 10,000 divided by 10 is going to give us 1,000. 1,000 divided by 10 is going to give us 100. And 100 divided by 10 is going to give us 10. So we have 2,300 divided by 10. Let's move that over one space to the left, and we're going to have 230. 438 divided by 10. We're going to move that decimal place over, and that's going to give us 43.8. 2,710 divided by 100. We have to go two places over this time because we're dividing by 100, and that's going to give us 27.1. And we have 73,863 divided by 100. Well, we have 100. We need to move that decimal place two spaces to the left. So this is going to give us 738.63. Understanding the concept behind the powers of 10 can help you understand the metric system and conversions because, as we've seen, it's based on powers of 10. This is a visual representation that will show you the sections set off here with the green brackets actually increase or decrease by a power of 10. You'll notice the sections with the yellow increase or decrease by a power of 1,000. So the part in the green, if you're moving in that part of the system, you only need to move the decimal one space because it's different by a power of 10. But if you go to the yellow sections, you're going to have to move the decimal three places because it's a difference of 1,000. Do not let this stress you. I'm going to show you some visual representations and talk you through it. It's not going to be difficult at all. As we've mentioned, the metric system is based on power of 10. Because it's based on the power of 10, it's easy to convert within this system because we are essentially multiplying or dividing by powers of 10. So this will be the metric system. we're going to have the section in the middle be our base. So you can have kilo, hecto, deca. We have our base, deci, centi, and milli. Deca is close to the K, so it's going to have the hard K sound. We have two D's here, so a way to remember that is deca is close to the K, and you'll see deci is close to the C, so it's going to have more of the soft C sound. Our base can be mass, which would be gram. It can be volume, which would be liter, or it could be distance, which would be meter. So that's why we put base there in the section in the middle, because this is the metric system and it can help you with either mass, which is grams, volume, which is liter, or distance, which is meter. So you're going to use these same prefixes whether you're dealing with grams, liters, or meters. The metric system has the same prefixes whether you're dealing with your base of grams, liters, or meters, but you cannot convert grams to meters or grams to liters with this conversion method because you're actually looking at two separate types of measurements or two different bases. This technique will work if you're converting within the system from like grams to milligrams, liters to milliliters, meters to millimeters. So you cannot go grams to milliliters though, because that's not going to be the same system. We know the metric system is a system of measurement based on the power of 10. And again, it's easy to convert within the system because we are multiplying or dividing by powers of 10. In this case, for our example, we're going to be multiplying. And the reason this is going to be helpful to know is because you can move your decimal place one space when you multiply by powers of 10. Our base here in the center can be either mass, which is going to be grams, it can be volume, which is going to be liters, or it can be distance, which will be meters. Don't overthink this. It'll be clear as we move through the slides. So our prefix K for kilo is actually 10 times bigger than the H hecto, which is going to be 10 times bigger than the D here for deca. That's going to be 10 times bigger than your base. That's going to be 10 times bigger than deci, which is 10 times bigger than centi, which is 10 times bigger than milli. Don't make this hard. We're just going to move through powers of 10. Now your base, like I said, can be mass, which is gram, it can be volume, which is liter, or it can be distance, which is meter. We're going to continue with this concept of the powers of 10. And again, it's easy to convert within this system because we're essentially multiplying or dividing by powers of 10. And in this case, we're going to divide. So we have our metric system here with our base, and we're going to start with milli, which is 10 times smaller than centi, which is 10 times smaller than deci. That is 10 times smaller than our base, which is 10 times smaller than deca, which is 10 times smaller than hecto, which is 10 times smaller than kilo. Again, our base is going to be either mass, which is gram, volume, which is liter, or distance, which is meter. Let's continue with this concept and put it into practice. The metric system is a system of measurement based on the powers of 10. And like I said before, it's easy to convert within the system because we're just going to be multiplying or dividing by powers of 10, which means we can just slide our decimal. So we have our metric system here, and our little sentence is going to be King Henry died by drinking chocolate milk. If you can remember that, it can help you get the system in order so you can do conversions in the system. And the B for by is going to stand for our base. And remember, our base will be either our mass, which is grams, our volume, which is liter, or our distance, which is going to be meter. And our question is going to be 1 liter equals X number of milliliters. Now, from nursing school or your courses, you're going to remember that this is going to be 1,000, and it's pretty straightforward. But here's a visual representation of it. So when you move on to more difficult ones, it'll be easy to slide through the system. We're actually going to have our base be liters because our question asks about liters. Now, we're going to have to move to where we want to go, which is going to be milliliters. You're starting with liters, so put your pencil on liter and move to where you want to go, which in this case is milliliters. So we're going to move from liters to deciliters to centiliters to milliliters. And do you see how we slid forward 3 spaces? Well, we need to move our number forward or our decimal forward 3 spaces. We're going to go to the right. We started with 1 liter, so that's what we have. Now, we don't have a decimal in this one, so we have an implied decimal. A whole number has an implied decimal at the end. You may not see it, but it's there. So if you don't have a decimal in your number, it's a whole number, just put a decimal at the end. We can see that we moved our arrows to the right, so we're going to have to move our decimal to the right. We went 3 places to the right up on our chart, so we need to move forward 3 places to the right here. And we have some empty nests. We're going to put eggs in it, and that's going to give us our answer of 1 liter equals 1,000 milliliters. With the practice question we just did, we were able to slide through the metric system. Now you can do the same scenario, but you can actually do it with an equation. For this question, it would be 1.5 liters equals X number of milliliters, but this will require some memorization in order to convert. You have to remember that 1 liter equals 1,000 milliliters. There are shortcuts that we take. It's if 1 liter equals 1,000 milliliters and a half a liter is 500 milliliters, then 1.5 liters is 1,000 milliliters plus 500 milliliters, which equals 1,500 milliliters. I prefer just to slide my decimal, but if you continue with this equation, you would have 1 liter equals 1,000 milliliters, which is the same as 1.5 liters equals X number of milliliters. And you're going to cross multiply on an angle and then divide. So you would multiply the 1,000 milliliters times the 1.5 liters, which gives you 1,500. And you're going to divide that by your 1 liter. So 1,500 divided by 1 equals 1,500. It seems a lot easier for me just to slide your decimal. So we'll continue to practice. And again, the metric system is a system of measurement based on the powers of 10. And it's going to be easy to convert in this because we're just going to multiply or divide, essentially sliding our decimal left to right. Here's our metric system with King Henry died by drinking chocolate milk. And we remember the B in by stands for our base. And it could be mass, which is grams, volume, which is liter, and distance, which is meter. Our question is 1.5 liters equals X number of milliliters. So we know our base is going to be liter. We're starting with liter, so we put our pencil on liter and move to where we want to go, which in this case is milliliter. So we're going to move over 1, 2, 3 spaces. Here's our question, 1.5 liters. So we moved our arrow to the right up here. So we're going to move our decimal to the right. 1, 2, 3 spaces. We have empty nest, put eggs in it, and that's going to give our answer 1.5 liters equals 1,500 milliliters. We're going to continue our practice, and our question is going to be 2 liters equals X milliliters. We're starting with liters. That's what we have for our formula, so we're going to have that as our base. Since we're starting with liters, we put our pencil on liter and move to where we want to go, which in this case is milliliters. 1, 2, 3. Our question is 2 liters equals X milliliters. We're going to go towards the right with our arrows, so we need to move our decimal to the right. And remember, this was a whole number. It didn't have a decimal. It has an implied decimal at the end. If you have a whole number, just put a decimal at the end. And since we went right up here with our arrows, we're going to go right with our decimal. 1, 2, 3. We have empty nest, put eggs in it, so we know that 2 liters equals 2,000 milliliters. We'll continue our practice with our King Henry died by drinking chocolate milk, and we know the B in by stands for base, which could be mass, which is grams, volume, which is liters, distance, which is meters, and our question is going to be 1.8 liters equals X milliliters. We know that this formula is going to be requiring liters, so that's going to be our base. We're starting with liters, so put your pencil on liters and move to where you want to go, which in this case is milliliters. 1, 2, 3. So we have 1.8 liters. We moved our arrows to the right up here, so we need to move our decimal to the right. So we're going to go 1, 2, 3. We have empty nest, put eggs in it, and that gives us our answer of 1.8 liters equals 1,800 milliliters. Let's continue our practice, and our question is going to be 1.725 liters equals X milliliters. We're dealing with liters, so that's going to be our base. We're starting with liters, so put your pencil on liters and move to where you want to go, which in this case is milliliters. We move this 3 spaces. So our question is about 1.725 liters. We went to the right up here, so we need to go to the right with our decimal, and we're going to go 1, 2, 3. And that's going to be our answer. 1.725 liters equals 1725 milliliters. This feels pretty straightforward when we're moving from liters to milliliters, and we remember that from school because those are equations that we use a lot or numbers that we use a lot. But what if they were asking you 1.25 liters equals how many centiliters? That's going to require some memorization unless you use the concept of the powers of 10. Your memorization would be that 1 liter equals 100 centiliters. A shortcut you could take is if 1 liter equals 100 centiliters and a quarter of a liter is 25 centiliters, then 100 plus 25 equals 125 centiliters. Or you could do it as a formula with 1 liter is to 100 centiliters what 1.25 liters is to x centiliters, and we would cross multiply on the angle and divide. So we would multiply 100 times 1.25, which gives us 125, and then divide by the 1 liter. So 125 divided by 1 is still 125. It's actually easier just to slide the decimal, and you don't have to rely on so much memorization. So we'll continue with the practice. We'll do the same problem we did on the previous slide, but we'll use our technique of just sliding the decimal. So if we have 1.25 liters equals X number of centiliters, we know our base is going to be liters. You're starting with liters, so put your pencil on liters and move to where you want to go, which in this case is centiliters. So 1, 2. We're starting with 1.25 liters. We moved our arrow 2 places to the right up here, so we need to move our decimal 2 places to the right. We go 1, 2. And that's our answer. 1.25 liters equals 125 centiliters. And we'll continue to practice. In this case, our question is 1 meter equals how many centimeters? Well, we're not dealing with liters anymore, so our base is going to have to be meters. It's still the same concept. You're starting with meters, so we're going to put our pencil on meters and move to where we want to go, which in this case is centimeters. So we're going to move 1, 2 places. We have 1 meter. I don't see a decimal, so there's an implied decimal at the end. And just like we moved our arrows to the right, we need to move our decimal to the right. So we're going to go 1, 2 places to the right. We have an empty nest, put eggs in it, and that's your answer. 1 meter equals 100 centimeters. We'll continue to practice. Our question is going to be 1,725 milliliters equals X liters. We know our base is going to be liters because we're dealing with liters. You're starting with milliliters, so put your pencil on milliliters and move it to where you want to go, in this case, liter. 1, 2, 3. Well, our number is 1,725. We moved our arrows to the left, so we need to move our decimal to the left. I don't see a decimal, so there's an implied one at the end because this is a whole number. So we're going to go 1, 2, 3. That's going to be our answer. 1,725 milliliters equals 1.725 liters. Our next question is 125 milliliters equals X liters. If we're not going to slide our decimal like we did through the previous questions, you're going to have to rely on some memorization. In this case, 1 milliliter equals 0.001 liter, a thousandth of a liter. A shortcut you can take is if 1 milliliter is a thousandth of a liter, then 125 milliliters equals 125 thousandths of a liter, which is 0.125 liters. You can do the formula as 1 liter is to 1,000 milliliters, what X liters is to 125 milliliters. Do your cross multiply on an angle, which is going to be 1 liter times 125 milliliters, which gives you 125. You would divide that by the 1,000 milliliters, so 125 divided by 1,000 gives you 0.125 liters. Since I know the metric system is based on powers of 10, I'd rather just slide my decimal. So our question is going to be the same one as the previous slide. 125 milliliters equals X liters. I know this is liters, so my base is going to be liters. You're starting with milliliters, so put your pencil on milliliters and move to where you want to go, in this case, liters. So we're actually going to move our arrow to the left. 1, 2, 3. Our number is 125. Now we moved our arrows to the left. We need to move our decimal to the left. I don't see a decimal here, so it's implied. I'm going to go 1, 2, 3. And I'm usually going to have a leading 0 before decimal. If you have a decimal with no number before it, put a leading 0 because it helps eliminate confusion. But that's going to be our answer. 125 milliliters equals 0.125 liters. It can feel a little trickier if you're using prefixes that we don't normally use. In this case, 1.68 deciliters equals X milliliters. If you're not sliding your decimal with our previous method, you're going to have to rely on memorization, which is 1 deciliter equals 10,000 milliliters. A shortcut we can take is if 1 deciliter is 10,000 milliliters and 0.68 deciliters is 6,800 milliliters, then 10,000 plus 6,800 equals 16,800, and the formula would be 1 deciliter is to 10,000 milliliters, which equals 1.68 deciliters to X milliliters. Cross multiply on the angle, which is going to be 10,000 times 1.68, which gives you 16,800, and you would divide that by the 1, which would give you 16,800. I would prefer just to slide the decimal. We'll continue our practice, and our question is going to be like we did on the previous slide, but this time we're just going to slide the decimal instead of doing the formula. So 1.68 deciliters equals X milliliters. We know we have liters. That will be our base. We are starting with deciliters, so put your pencil on deciliters and move to where you want to go, in this case, milliliters. 1, 2, 3, 4. So our number is 1.68, and I'll need to move my arrow to the right, so I'll need to move my decimal to the right. 1, 2, 3, 4. I have some empty nest. I'm going to put eggs in it, and that gives me my answer. 1.68 deciliters equals 16,800 milliliters. We'll continue to practice. Our question is 1 milligram equals X micrograms. I know my base is grams, so I'll put that for base. But I see a problem here because micrograms is not on here, so we need to review our metric chart. As we saw before, the area with the green brackets are different by a power of 10, but the areas with the yellow brackets are actually different by 1,000. We'll need to account for that as we slide in the areas with the yellow brackets. It's still going to be straightforward. Our question is 1 milligram equals X micrograms. Since I don't see micrograms on here, I'm going to add it. Now again, converting from milligrams to micrograms is a little bit different because the difference between the units isn't 10 anymore, it's actually 1,000. So we must move the decimal 3 places. Don't worry, there's an easy way to remember it. We're just going to put MCG for microgram, and we're going to count each of the letters because we're moving it 1,000. We're going to start with milligrams, that's where we are, and we're going to move over 3 places. And our number was 1 milligram. We moved our arrow to the right. We need to move the decimal to the right. 1, 2, 3. I have empty nest. I put an egg in there, and that is my answer. 1 milligram equals 1,000 micrograms. We'll continue. Our question is 2.5 milligrams equals X micrograms. We need to move it 3 places. Put your pencil where we start on milligrams, move to where we want to go. Our number is 2.5. We moved our arrows to the right. We need to move our decimal to the right. 1, 2, 3. Empty nest. Put some eggs in there, and that's going to be your answer. 2.5 milligrams equals 2,500 micrograms. And we'll continue our practice. The question is 2,500 micrograms equals X milligrams. Again, converting is going to be a little bit different because we need 3 places. I know our base is grams. We're going to add our micrograms here and just count every letter. Nothing else has changed. We're still moving the same way through the system. So we're starting with micrograms, so that's where we're going to put our pencil on microgram and move to where we want to go, which in this case is milligram. 1, 2, 3. Our number was 2,500. We moved our arrows to the left, so we need to move our decimal to the left. 1, 2, 3. That's going to be our answer. 2,500 micrograms equals 2.5 milligrams. Using the concept of the power of 10 can help you move really quickly through these conversions. But be careful not to overthink this. Just remember that when you multiply a number by 10, you move the decimal place one space to the right. When you multiply a number by 100, you move the decimal place 2 places to the right. When you divide a number by 10, you move the decimal place 1 space to the left. And when you divide a number by 100, you move the decimal place 2 spaces to the left. Please note that this presentation is a brief overview only. It is appropriate and may be used for review and continuing education purposes. Dosage calculation and metric conversions may involve more than this presentation covers. This content is under copyright protection and may be used with permission from the developers. Please visit pegasuslearning.org for more information. Thank you for your attention to this resource hosted on the Pegasus Learning Platform.